Thank you. I'm Brad Neuroth from Bausch+Lomb, and I want to talk to you about a project today that we started in a site in Greenville, South Carolina. It's a OTC site for us that makes pharmaceutical products for eye health. And over the past 2 years, we've worked on a project to try to begin our journey to a connected enterprise. Did I turn it off, or is it? Which button am I? Okay. Which one? The one in the middle there? Yeah, okay. All right. So to begin, I want to introduce you first to the parties that were involved in this journey with us, because we didn't do this alone. I want to review the business drivers that helped define the project goals for this project. Talk about the major steps in the project definition and documentation, because documentation for us as an FDA-regulated industry is very important. I give you an overview of the system hardware and the design of the system, and discuss the major features that helped us realize these goals. And in order to help you understand where we are on the journey, I want to talk about some of the results we've had from this project, but especially important with the project that we hope begins our path forward. I want to talk to you about some of the lessons learned and recommendations that we have that we can share with you that may help you in your journey to a more connected enterprise. And to wrap up, I want to share with you kind of some of our next steps along the evolution as we proceed. So to begin, I'd like to talk about who is Bausch Lomb. Bausch Lomb was founded in 1853. You're probably all familiar with the name. John Jacob Bausch and Henry Lomb founded it in Rochester, New York. And over the past 162 years, we've made everything from Ray-Ban sunglasses to contact lenses, binoculars to microscopes, surgical devices for the eye, as well as, just general eye drops. And back in August of 2013, Valeant Pharmaceuticals acquired Bausch, and now we're a wholly owned subsidiary of Valeant Pharmaceuticals. And we're now focused on just the pharmaceutical aspects. So we have 3 major divisions, and where U.S. manufacturing is based in Rochester, New York. That's where we do all of our contact lenses. We also have plants in Clearwater and Tampa, Florida. We have a plant in St. Louis, Missouri, and we have a plant in Greenville, South Carolina. The plant in Greenville is the one I want to talk to you about today. But our 3 main business areas are vision care, surgical, and pharmaceuticals. These are some of the products that we make. The BioTrue product there, which is a contact lens cleaner, is one of the primary products that come out of this plant in Greenville, and that's the manufacturing system I'm going to talk about is for that particular product. So to help us on this journey to a more, IT/OT, connected enterprise, convergence of systems, we enlisted Malisko Engineering. They're experts in automation and validation. We picked them because they had experience in our domain space. So they've done projects with our competitors. They do projects in pharma, which is important to us. People have to know and understand the validation and documentation requirements that the industry requires. They're headquartered in St. Louis, and we worked with their St. Louis office. And Steve Schnabel is here from Malisko. He's the Director of Engineering and Information Technology, and he helped us in this role toward to ensure success with this project. So as I mentioned, the project we're going to talk about is actually done in this plant in Greenville, South Carolina. It's a aseptic lens care plant. And just recently, they celebrated the fact that they've made their 4 billionth bottle of lens care solution. So it's a plant that makes a lot of liquid products. In 2012, we started a program to develop a more robust automation master plan, and the site identified the greatest need to be the replacement of an obsolete Fisher-Porter DCS system that actually controlled the make process for the manufacturing of these lens care products. And the system along the way, working with IT, the automation folks, the folks in our engineering group in New York, Malisko, the operations team, we all got together to kind of work through the project and develop a path forward here. But I'm also, as I mentioned, the system was obsolete. So we had really two primary challenges. One, we had to deal with the obsolescence of the system, which was about 30 years old. It was put in when the plant was first built back in the early 80s. The other issue we had to deal with was the operators. Nearly all of the key operators were nearing retirement. So most of them had been with the plant since the system started up. So they were very familiar with the process, they were very familiar with the products we make, and they were all about ready to retire. Oops. Talk to you about Malisko. So the project goals for this project. This was the legacy DCS, so the biggest thing, this was a maintenance of business opportunity for us, and it was on our critical utilities and also our main bulk manufacturing system. One of the big issues we had here is we couldn't really do this upgrade very quickly because of the documentation requirements and validation requirements. So we had to find a way to not rip and replace the system, but to gradually transition from the old to the new. And we really did that tank by tank. So we had over a dozen tanks that had to be individually converted from one system to the other. So what we did is we put the PLC, the new PLCs, the new I/O, in the same cabinets that the Fisher-Porter system was in, and we slowly cut over the system one tank at a time, and we validated it a piece at a time, which was very challenging. So we had to pick the right solution that would actually enable us to do that. One of the main goals we had out of this is we wanted to start to enable and get more information out of the system. The system before was pretty locked and proprietary. We didn't have a lot of capability to look at any of the data. We stored the data in the system, but it wasn't a real historian. It didn't give us a very long-term view. We couldn't go back and analyze much of the data, and the data was pretty much captured inside the control room and not a lot of visibility outside. So the operators could look at some simple trends, but any long-term analytics, the things that we'd like to do and we could do today, we couldn't do with this system. So, like I told you, the system was beyond end of life. It really wasn't supportable. There was really only one or two, maybe two engineers that could support the system for us, and both of those were older gentlemen that had retired. So the people that originally did it in the 80s, they weren't available. Documentation really wasn't available. Back in the early 80s, from a FDA standpoint, regulations were just coming out that required us to document systems much more than we had done before. And so limited documentation was really available with this system. So one of the things we decided to do was to invest with Malisko to develop a basis of design. So really a reverse engineering of the system. We needed to define how it worked. We needed to build an architecture for validation that we could use as a strategy to first simulate the system and then cut over tank by tank, system by system. We also had to develop a validation strategy, which was very important to us, and make sure that we could maintain a state of compliance, because as we were doing this cutover, we were constantly producing product because we just couldn't afford to take the plant down for that long. So as I mentioned to you, documentation is very critical in our industry, and the initial system was designed without this documentation. So we had to rely on our operators and a couple engineers within the site that knew the system most intimately. And Malisko had to download, the code that we had out of the system, analyze that, try to reverse engineer the pieces of code that they could get to. Countless hours of interviewing operators and the engineers that had knowledge of the system to try to create this new design, because the goal here was to try to do a like-for-like conversion. We knew the new system was going to give us more features, but in order to maintain compliance and validation, we needed to slowly convert the system like for like. To redesign and document this system, we obviously used an S88 modeling tool. So a traditional batch management system was deployed, and that gave us the ability to modularize the design and was a great help in helping us simulate and also validate this tank-by-tank replacement. During the modeling of the system, there's not a lot we can really change, because as we register products in the make process with the FDA, we have to make them the way we say we're going to make them, and if we want to change the way we make them, we have to refile. Sometimes that's refiling in every country we sell the product to. So it's a great concern to kind of keep the process the same. So one opportunity we were able to change was the sterilization process. Sterilization was an opportunity where we could change, where we didn't have to follow that rigid process. So we found kind of some unexpected benefits in our like-for-like transition by using the modeling tools and help us to streamline our sterilization process, which really goes to and is an important benefit from a capacity standpoint, because sterilization isn't making product, it's just preparing to make the next product. So the faster we can sterilize and be sure that we're safe to continue on with the next batch, the better. Now I want to talk a little bit about the system architecture. The system was built on HP servers. It had 8 virtualized images. We used FactoryTalk as the HMI servers for both primary and secondary in a redundant pair. We used ACP Thin Manager because we did thin clients for all the new operator stations. As I said before, we used batch servers. We had FactoryTalk Batch, again, both in redundant primary and backup. We deployed a FactoryTalk Historian to collect the data, which was really, much better than the system that we had. We also have a Microsoft SQL Server that's deployed for all the event and transactional data on the batch where we collect and report from. And as I said, we had FactoryTalk View thin clients. We also had 2 engineering workstations. Those engineering workstations we used for configuration of the system and validation, but also initially for simulation of all of the processes before validation. One of the real benefits we had here too is, as we deployed this new system, we developed a VPN connection for Malisko. We've not really done that in the past in this plant, really because we don't like to have people inside our systems. As a regulated industry, it's very dangerous, so we typically run very closed systems. But we knew we needed here to be able to do this development, do this simulation, and we wanted to enable Malisko to do that from their offices and to be able to support us as we were transitioning over. So if we validated a tank and we're running the system and we have an issue in the middle of the night, we needed someone to help us, because as we were in the middle of this process, we didn't have people knowledgeable on site to do it. This is just an example of the system architecture that we deployed for the system. So you can see the redundant servers, the stack-wise Cisco switches. We have redundant control logics processors, our thin clients for view nodes. So it's a very traditional, redundant batch control system using PLC-based technology. And we really like that approach because in our packaging side of the house, which is really the other half of the plant, all the packaging lines from our OEMs pretty much run Rockwell technology. It's very common for us. We don't really invent any systems ourselves, so we're buying from OEMs in almost every case in the packaging side. And so with that, we've got very common technology now between our make process and our packaging process, which helps us because now the technicians and the engineers that support the packaging side can more easily transition to help support the manufacturing side. I'd like to talk a little bit about our new HMI layout. We used widescreen monitors, which was very different from the RGB color monitors that they had on the older Fisher-Porter system. As we developed this HMI, the operators were used to tank screens, and so the tank screens pretty much mimic, like for like the existing tank screens. Obviously, we have a lot more capability with this system than we have with the other, but one of the advantages we gave the operator was a more consistent look and feel, easier navigation from the 80s system to now, the ability to have multiple tanks showing in a more, so they can easily get from one place to the next, easier to control alarm and event management for the operator. So they really like the larger, more vibrant screens and also the ability to have multiple screens up at a time, which they really couldn't do before. So as I mentioned, this FactoryTalk Batch, we had primary and secondary servers. And one of the advantages with the batch system is we have quite a number of SKUs for different products. And so we basically validated a default recipe for these products. And once we validated that, it was much easier for us to transition the new products in, transition the new tanks in. So the S88 software that we used was, the previous system we had really didn't have a full S88 compliant model. Okay, so modeling the system made future upgrades easier and changes easier along the way, and certainly made the transition from tank to tank in terms of being able to just almost copy and paste in new tanks as we validated from one tank to the other. One of the other things we did is we developed a custom screen to be able to start the orders in the system, start the different batches. And one advantage that had for us is as we're transitioning to electronic batch records, we wanted to kind of pre-plan the interface between how we started a batch and how we collected the batch information. And so this was kind of a precursor to the conversion to an MES. Okay, so as I said, the data historian was a big benefit for us. We hadn't really had the ability to collect data in this kind of volume before, or to be able to look back and do batch-to-batch comparisons like we can today. We have all that system, all the information from both our site utility systems as well as the manufacturing system, all in this Rockwell Historian. So if you can advance the... As I mentioned, we also have another SQL database where we store data for alarms and events, and now for reporting, we have both the historical database and the alarm and events database we can report from. We had in the old system, and we had to maintain in the new, a set of batch reports, because those batch reports get attached to the batch record for filing for the FDA. And so we had to develop those reports. But those reports now with this system, more modern technology, are much easier to develop. They weren't proprietary, and the tools now are things that our IT folks and our automation folks are much more familiar with. So it's much more powerful, and we can create more information from the system. So these are examples of our typical batch reports on what we would attach to the batch records. And that data is taken from the SQL tables and also the historian database. Data analysis. Now, this is an area where we really had a benefit here in the plant. We never really had the ability to really look clearly at a batch. And so now the operators have some standard trends we've built for them that they can go in and historically compare one batch to the next, or one sterilization cycle to the next. So we can actually, look for the golden batch now, which we really couldn't do in the system before. We have rolled out kind of some common trends that we would think everyone would use, and built them in kind of a library for the operators and the engineers to look at. But the system's flexible enough that we can easily build ad hoc queries into the data. Our future plans are to kind of roll out more dashboard approach. So either mobilely from a tablet, engineer's office, operations supervisors' offices, they can see these batches as we make them, which before they had to walk to the control room and talk to the operators. It just wasn't modern. Like I said, a immediate benefit to the system design was the fact that it was redundant. It was also built on COTS server hardware, standard PLCs, standard software switches that are widely used at the site, which is a real benefit for us. The old system was kind of a one-of-a-kind. We had a set of spare parts in our stock room that was dedicated to that system. And now the spare parts we have are really the same spare parts we had for the rest of the systems in packaging. Remote access to us, it's really turned out to be a big benefit. We can have people in New York, people in St. Louis with Malisko, people in the plant in Greenville, all working together via teleconference or via VPN connections into the plant, helping the operators. The other thing is, having built this on Rockwell's PlantPA standards, we really tried to leverage as much as we could. And our philosophy with this project was not to build anything, but to use everything pre-built that we could, all the standard screens, the standard objects. Because in our industry, that level of software that's tested and proven is much easier for us to validate. There's much less risk. So our long-term benefits here is that our hope is, as we've now unleashed this data from the control room, that now we'll be able to expose it not only locally, but also from a corporate level to the corporate level, so that we can actually see how we're producing. And getting real-time data to the process engineers will help them with new product development and line extensions, because before the data was kind of trapped in the system. We just couldn't get at that much of it. Using a familiar programming standard, programming environment with Rockwell helps the folks in the plant because they're familiar with that system. Use of the S88 model and phase manager opens up options for further automation of our mixing system. This mixing system, like I described to you, is built back in the 80s. It was largely manual. And the conversion that we did was really like for like, because of the way the products had been designed, the way we'd registered with the FDA. So now our opportunities are much greater to be able to go in and try to automate some of those steps and get rid of some of the manual steps that the operators do where mistakes get made and things like that. And then our hope also is to, with future MES, to be able to pass the production orders down, actually enable the plant to move to a more electronic batch record, because today both the manufacturing and packaging batch records are completely manual. We really learned a lot from this process, and just kind of want to go through some of the bullets on lessons we learned and recommendations that we would have. With Malisko, we created a comprehensive URS. Really didn't exist before with the age of the system. But it's very important because we got it approved by all the key stakeholders: IT, operations, site engineering, regional engineering. And we tried to get inputs from all those people to develop that URS so that when we're going through the build process, we didn't have any surprises at the end. We also found this initial basis of design effort that we went through invaluable with a system like this, because without any documentation on this old, obsolete DCS system, we really needed to have a good starting point and a good way to develop and reverse engineer the system. We typically use a formal supplier selection process. We use a Pew matrix. We agree on the criteria up front. We go through and evaluate the different suppliers. And so that was a real valuable tool, because it allowed us to kind of choose Malisko as a partner, and for the reasons we did, their domain experience, their experience with the platform that we were getting ready to build. So I strongly recommend a good, strong supplier recommendation process. And that, like I say, that led us to, basically aligning our supplier both on the automation side and the integration side with our business needs. Create and follow a detailed project plan. We had to do that because we were transitioning at shutdown periods throughout the year. We usually have 2 major plant shutdowns, plus we were trying to do tanks in between the shutdowns as we were converting. And it was really important for us to have a detailed plan, because we had these very limited windows of opportunity with the operations group. Include the SMEs in the design reviews. This was something that the project really couldn't succeed without doing. I mean, this whole IT to OT convergence, it's as much about systems, but it's more about people. I mean, having the IT folks involved with the decision-making, the architecture, having the automation folks and the operations folks all working together, and also along the way, because our operators were so knowledgeable and the system was not well documented, involving those operators in all those discussions and those design reviews really helped us get this right from the start. So, what I would say is that as we're trying to lay our framework for Connected Enterprise, we had early and often meetings with those folks, and we really kind of made them a part of the process. So our next step, we really haven't completed this transition to a connected enterprise. We have a new control system. We've got a lot of features from that control system we think are going to benefit us. But now I think it's time that we start thinking about how we're going to continue this transformation. So one of the steps we're taking to continue our success is we're trying to develop a more comprehensive automation master plan, and also building a process control network and expanding it to a more highly available automation network. The system that we built, as you could see, it kind of is a network unto itself. And what we really need to do is expand that out to the plant, build more defense in depth for cybersecurity, build more better connectivity for our remote engineers, for our remote integrators. We need to have a more robust process. And today, most of our systems, again, are maybe well automated, but they're still islands. And we're trying to more remove that isolation and be able to connect those into a new process control network. We're continuing to add to our historian and SQL database. We have future expansion plans at the site, and this tool is just going to be a platform for us to enable more data collection throughout the plant. And we're really, using this vantage point and historian. We're starting to roll out data to the desktop initiative and build some, like I said, some standard trends. But one of the things we want to do is, as we're kind of teaching people how to use these tools, which are relatively intuitive, every time we have a new use case where we have used the data to solve a problem or use the data for root cause analysis, we try to publish that out to all the group, a fairly wide communication, because we want people to understand the value of that data and understand the system that we have and be thinking about how to leverage it. That should be the first thing they think about is, where's my data? What can the data tell me? And we haven't really been doing that in the past with the system. So in order to leverage the system in bulk manufacturing, we're discussing further ways to automate the process. Like I said, this process was very manual, so we've got projects now to start to automate some of the additions, some of the transfers out to our fill lines. So I hope, as we discuss this, like I say, this was a fairly traditional batch project for us, but it really led us down the path of both a connected enterprise and this, IT to OT convergence. So I hope our journey's helped you, and as you consider things and in your plans and how you want to proceed in the future, that we've given you some things to think about. Thank you.